this is going to be just a video on how to like know how to start some problems. So there's basically four major types of problems that we're going to see. We've got a problem that looks like this, sometimes equal to 20, sometimes equal to 0, depends. We've got problems that look, that was a terrible line. We've got a problem, I can do this technology. Boom, nailed it. We've got problems that look like this. Get a little more complicated. We've got problems that look like this. Actually, I don't like that one at all. Let's do something like that. And then we've got problems that look like this. And then we've got problems that look, I think one more. Actually two more. And shoot, one more. I had another one coming. We'll come back to it, I guess. Okay. Oh, yeah, okay, I know what I was going to do. All right, so basically if you look at all the different kinds of problems, I'm basically counting the number of x's. So if I focus on like the x's in two positions, I've got this kind of problem, I've got this kind of problem, and I've got this kind of problem. The goal, oh, and this one here, equals 0, let's say, all right? So the goal with all these problems is first to make them all equal to 0. So it's very common for you to see something that looks like this, equals -6, let's say, all right? So whenever you see an x in two positions, it better equal 0 first. So if I'm like, oh, I wonder what I need to do to all these problems, the first thing I count is the number of x's, all right? So I got 1, 2, 3. So all these, it's much more likely that you're going to run into a problem that looks like this than one of these, all right? And so we'll talk about this one in a second, but if you're looking at strategies, it's count the number of x's. Now, if your x's are already in parentheses, then you've already had a box problem finished for you. So this is like the last step in a box problem. This is a box problem, this is a box problem, this is a box problem. Those are all box problems. So I'm just going to do a couple and just kind of go step by step. So if you're like, oh, I want to just tell me how to do some stuff, then I guess this might be a long video because I'll go through all the problems for you. All right, so I'm going to start with the simple one. So the first thing I notice is I've got an x in two positions, and then I'm going to make it a box problem. But I can't do that until it needs to equal 0. So if it doesn't equal 0, I have to fix that by undoing whatever this is. So I'm going to put a +6 on this side, and what I do on the left side, I do on the right, or vice versa. And then I've got this problem here, x squared plus 5x plus 6. I always put the number in the back because when I'm doing the area models, the number always goes in the corner. So I fill out my box, x and x, and then two numbers that multiply to 6. The first combo that I can think of are 3 and 2. So 3x and 2x, which together gives me 5x, which is this term in the middle. So then I go from the insides to the outsides. And now I've got a problem that looks just like this, see? So this double parenthesis here is the last step in a box problem. So when I give you two parentheses, don't freak out and do a box. You don't need to do that. I've already done all the work for you. I've given you this step of the box problem. I just need you to finish it off. So split and solve. So split this apart and solve it. So I've got x equals -2 here, and then x equals -3 here. So we've got two of my answers from the double parentheses. So if I have, again, a question that looks like this, and you say to yourself, okay, in how many places do I see an x? 1, 2. All right, if it's two x's, I always have to make sure it equals 0, which it does. And then it's a box problem that's already been done for me. So I set each part of the parenthesis equal to 0 and solve them independently. So subtract 3. And then subtract 7, and then divide both sides by 2. Ta-da. I keep going. All right, here's another one. X is in two positions. I'm just going to clean this up, make it look a little nicer. So we've got this problem that's got 2 x's. But now the difference between this box problem, which again, there's 2 x's in 2 positions. So I double check that it makes sure it equals 0, which it does. And then I go to draw my box. But as soon as I draw my box, I realize, wait, there's nothing to put here. Because the thing that goes in this corner here is the number in the back, which here was 6. But a number doesn't exist here. I mean, I could put 0, but 0 is going to make this whole thing, you know, disappear essentially, because zeros, you know, or make everything zeros. So it occurred to me that I drew the wrong type of box. So instead of drawing a box that way, I'm going to draw the area model this way instead. And then I'm just going to put the 6 here in the x. And I can do this in lots of different ways, but this is just one strategy. 6x times x is 6x squared. If I have a 6 here and I need a 12, then I need a 2 here. And since I have an x here and an x here, I don't need any extras. And then again, I'll go from the inside to the outside. The 6 and the x are already attached, so I don't need parentheses. But the x and the plus 2 are separate, so I need to add these components together. Equals 0. And then again, split and solve. 6x equals 0. X plus 2 equals 0. Do what I normally do, which is get x alone. Divide by 6 in this case, and that's 0. So again, here are my nice 2 answers from the 2x kind of problem. Okay. Let me change this problem slightly to make it a little easier. Well, a little more something. What's happening here with my zeros? There we go. And it's a little cleaner looking. So, same exact thing. Actually, maybe we can make it a little bit tougher. Tackle 2 birds with 1 stone. Okay, so we'll do one of these. So notice again, same exact pattern. I'm counting the number of x's, and if there's 2 x's in the problem, it's likely to be a box problem unless the box has already been done for you like this one. There are different kinds of boxes, the boxes that have space for numbers here in the corner, or the parts where the second part is missing. And you've got these kinds of problems. Same thing. X's are in 2 different locations. I'll highlight that again just to keep it consistent. So before I fill out the box, I need to make sure that it equals 0. So to make it equal to 0, I undo that 3x using its opposite. I put the x's in the middle. So that way the x squared is first and the number is in the back and the x is always in the middle here. All right. So then I'll fill out the box. I'm like going along, doing my merry thing. 2x, oops, I filled out the wrong way, but that's what it's going to turn out to be anyway. 2x squared, 2x and x, put a 1 there. 2 numbers that multiply to 1 are 1 and 1. So that gives me a 2x here and a 1x here. And that's a nice 3x in the middle, so 2x plus 1, x plus 1, life is all good, split and solve, etc. But what if we made this problem a little more challenging and imagine it was a plus 4x on the other side, or a minus 4x. So now, let's say your problem looks like this. And you're like, okay, I got this. There's x's in 2 positions. I'm going to add 4x to both sides. And then that'll make the 4x in the middle. And now you've got a problem that looks like this. The 4x's cancel out and they make a 0. Life is all good. Same exact thing, 2x squared, 1, 1. Uh-oh, now the 2x's and the 1x don't make that 4x in the middle. So if you remember, I just had a 3x there. I'm going to switch it to a 4x. And now you're like, okay, I don't think there's anything other than a 1 from a 1 to a 1. So now the box problem doesn't work. And that's where you're going to use your quadratic formula. So I'm going to zoom out a little bit. The quadratic formula is this. You're going to have it on the test, so don't freak out and panic that this really long, ridiculous thing is something that you have to memorize, which we used to make kids do, but alas, not anymore. All right, so that pressure's off. Okay, so remember, keep the goal in mind, which is all I'm going to do is replace all the numbers or all the letters with numbers. So these, like all the letters, are just a placeholder until we find out what the numbers are. So like, where do you find the numbers and what are they? So a is always the number in front of your x squared. So in this case, it's 2. And I always do this kind of labeling thing just so it's easier to find. B is the number in front of x. And C is the number all alone. All right, so here's your A. This is your B. And that's your C. And all I'm going to do now is do some replacing. So this is the opposite of B. So the B that I have right now is 4. So what I'm going to write down is the opposite of 4, which is -4. If this were -4, then what I would be writing here is a +4. So it's just a sign change. And that's the only time you're ever going to change this number or this number or this number. Everything else is the same letter with the same letter, same letter. The only changing you're going to do is the first number out in front, and it's the opposite of the B value. Then you've got this giant parenthesis, and then every time I make a replacement, I'm always substituting with parentheses. So 2 and then A. So in place of A, I'm going to write 2. Not because these match, but because A happens to be 2. And then again, B. B in our case is 4. So 4 squared minus 4, 4, A, C, C. See? Opposite of B, plus minus, B squared minus 4, A, C, all over 2A. And now once I have all that substituted, it's all just like a whittle down to one number. So take that. It's all one number. That's the easy part. Then downstairs, 2 times 2 is 4. That's easy. And then from here, brain or calculator, 4 squared means 16. 4 times 2 times 1 is 8. So 16 minus 8 is 8. And if that gets confusing, you can type that, literally that whole phrase into Desmos just the way as is. So parentheses 4 squared minus 4 times 2 times 1, and see, it equals 8, and that's the number I'm going to write underneath the square root sign here. Just make sure that when you're typing into Desmos or your calculators that you're not using a giant square root symbol. You don't want that whole phrase. Can I copy and paste that whole thing? Not on the desktop. So don't type in parentheses 4 squared, oops, minus 4 parentheses A times C. You're not going to want to put the root symbol in there because it'll give you the decimal version of this, and that's not what you want. You want the actual value. So see, like if you put that square root symbol in there, it's going to give you that decimal. I would rather have you do that without the root, and that way you can get the number here. So just type this in, 4 squared minus 4AC without this radical in there. All right, so that's how you do the quadratic formula. Okay, so that takes care of literally all, like most of the problems that are on the test, because most of the problems on the test have 2 x's in them. But let's just take a look at this one over here. If we've got a problem that looks like this one, we've only got x in one position. So this is a what's x with, how are they connected, how do we undo it problem. So everything outside the parentheses always first. So in this case, there's only one thing on the outside of these parentheses, and it's this. So when I'm solving problems that have just one x in them, I'm thinking the same steps about what's x with, how are they connected, and how do we undo it. It's about getting x alone. So I'd love to be able to do this, which is just like real easy, like, look, x is all by itself. Except you can't do that. You need a mathematical reason. So you got to undo. So we undo squares with square roots. The square root of 81 is 9 because 9 times 9 is 81. And the square root of a square is the absolute value. And here's where things get, revealing. It's you don't want to have these bars in your final answer. So you want to remove them, but you can't do that just on its own. So the bars don't care about the direction. So when you drop the bars, you have to reincorporate direction. So you've got to move left 9 and right 9. And so a lot of teachers will write plus or minus 9. Some people will write 9 and negative 9, and that's fine too. But just know that when you drop the bars, this 9 means left 9 and right 9. That's how we get rid of the bars. It was we reincorporate the direction. And now what you essentially have is two different equations. You have x plus 6 equals that positive right 9, and x plus 6 equals the left 9. And then you just solve them like two separate problems. And that's that. Occasionally there are some really, bizarre looking things. You can come back and I'll post that as well. But you get something that looks like this maybe. So negative 2x squared equals, I don't know, like 18. Actually, maybe I'll do like negative 3. Something like that maybe, okay? That's 27. So you get this nice, hold on, what's happening here? 27. All right, so you have this nice little easy problem. Not, and I shouldn't say easy, but you've got not a lot going on there, right? We've got this number in front, this number in the back. So big numbers first. To undo that negative 3, we're going to divide both sides by negative 3 because that's how we undo multiplication. Just undo the 7. There we go. So x squared equals negative 9. And then you're like, cool. X is almost all by itself. What's with the square? So we undo squares by square root. Square root of x is absolute value of x. And now the square root of 9. And you might be like, okay, cool. There's the 3. And then the answer is 3 and negative 3. And away I go. But again, nope. Because you got to think through the problems, right? It's not just autopilot. The square root of 9 is asking you what number times itself is negative 9. So we've got 3 times 3 does not give you 9. So this can't be your answer. So you're like, okay, fine. It's negative 3. But negative 3 times negative 3 is still 9. So negative 3 and negative 3 doesn't work. You're like, okay, fine, one of each. But that violates the definition of you multiplying the same number by itself. These numbers have to be the same, otherwise that's not what the square root means. So now we're out of options, which is exactly the point. This is a no solution. So the variety in those single x problems is much less than the variety with two x's. When there's two x's, it's the same procedure. It's all box problems. It's just there's lots of little details that get mixed up. So, and that's common, that makes sense. But the 1x kind of problems, what's x with? How are they connected? How do we undo it? And that's just basically all Algebra 1 really is. It's about trying to figure out what do you undo, why, how, and what do we do first in what order. Okay, I hope that really helps.